Hi, I'm Jay Botello with WildPackets, and we're going to talk about how new architectures and new traffic patterns are affecting the way deep packet inspection and network analysis is done. So we've talked so far a little bit about just where the 10 gig market is and about the challenges with 10 gig in general and moving from 1 gig to 10 gig analysis, and then talked about network recording at 10 gig and why that's important. Now we're going to look at some of these new architectures and new traffic patterns, mainly due to virtualization, and how that's also affecting deep packet inspection and network analysis. So we're going to look at three different approaches, just standalone VMs. Who would have thought? It's already that these are just kind of garden run-of-the-mill kinds of things, right? People wouldn't have thought that 5 years ago, but they are now. And then more about coordinated VMs, much more where the industry is at today with distributed virtual systems and how does that affect network analysis, and then the cloud as well, and what can we do with deep packet inspection and network analysis in the cloud. So standalone VM networking, you are probably all at least as familiar with this as I am, if not more. Multiple guests, a single host, a single box, trying to host a number of different applications. From a networking perspective, it typically has virtual network interfaces on it, right? And probably one, maybe several physical NICs on the box. Why do I bring that up? Why is that relevant? Because a lot of the things we've talked about so far in terms of packet capture, network analysis from deep packet inspection, deal with having to capture the packets from somewhere. And that's typically, in everything I've shown so far, from a physical port, whether it's a tap or a mirror port or a span port, it's been physical. And now that we get to this virtual environment, these NICs they're virtual. They're not really there. There's not something to go plug into, right? They act like a NIC, but they're not physical. It's not a physical port, and that's really the crux behind the problem with virtualization and visibility from really from any level, whether it's from a packet level or even from a flow-based level. So, standalone VM, probably not the best picture on the planet, but this represents the physical confines of a box that is now running a number of guests or a number of hosts. It has some virtual switches in it, right? And then some physical NICs as well, right? And then a bunch of virtual NICs down here. So there's a lot of networking from all these virtual NICs and any of these connections between these applications running within the box that now become invisible to the end user, right? So here we are. Any traffic that's maybe moving from this box to this box, maybe it's the database is running over there, and the Salesforce automation system is running over here. Traffic back and forth winds up being invisible to any of those physical links. So I can't capture the packets. How do I analyze that? How do I capture those packets? This just isn't a problem that we represent. It's actually been a problem in enterprise networking for a little while, that even I think still today is only just becoming something that people are addressing with the right kind of tools. So to do that on an individual virtual machine, I'll show you later how we capture those. So I'm actually going to go through the problems right now. So in the distributed virtual, now we have a single switch among multiple VM hosts. So now there's one VM host, and then we have one switch for all those hosts. It's a much more complicated environment in the sense that that picture we had before, now we have a number of those, and they are all connected by a distributed virtual switch. So now even traffic, not just traffic running between here and here, but traffic between here and here, or here and way over. All of that, it ends up being hidden because there's no physical interface. And same thing true in the cloud. And the cloud provides some unique problems of its own in terms of being able to capture, right? Depends on what type of cloud computing you're talking about, whether it's infrastructure as a service, software as a service, et cetera. And now let's address where to actually capture to solve those problems or take care of those blind spots that we just identified in virtual networking. So, first, before we get back to the virtual, how do we do it on the network? Well, on the network, we showed this earlier, on the network it's easy because the network has physical interfaces to be able to connect to. So we can use our network recorder, like our timeline, and connect right into either a switch or a network packet broker type device. We can be out at a corporate campus and use a real-time device like an OmniPliance Core to connect again directly into the switch at that corporate campus. Or we can use an OmniPliance Edge out at a remote office, a smaller box, less expensive solution, to still be able to do the same type of packet capture and analysis, just not at network speeds that are as high. And then, of course, we can use portable solutions to capture traffic as well, and virtual, which we're going to look at a little bit more now. So, on the vSwitch, how do we deal with that? Well, basically, what we're looking for is visibility into the intra-host traffic, and the way we're going to do that is we can actually run software. It's called OmniVirtual. We can run additional software on the host. So we would actually carve out some resources from the host for processing, carve out some resources for RAM, for disk space, and we could run software similar to what I was showing here, but just for capture analysis on the virtual machine. It will then have access to all the virtual switches and virtual NICs in that machine. For example, we run software here. Now we have access to all the virtual switches and virtual NICs on that machine. We're able to connect to that with OmniPeak, and we're able to see traffic that went back and forth, for example, between that Salesforce automation app and the database that was running on another part of that virtual machine.
So that would be your virtual machine in promiscuous mode capturing the traffic.
That would be right. Yeah, we'd run that right here. Right. We'd have right.
So why would you do that now that vSphere, for example, has span and remote span functionality?
Wouldn't necessarily do that here anymore. This is what people were doing a few years ago. There's still some people that do end up taking this approach, but it's even not an approach that we really recommend much to folks anymore. Mainly because you're also taking up a lot of resources here that you don't really want to take up with our software.
Yeah.
Right. So as things have gotten more complicated, right, just to that point, right, we have, with vSphere and other things at that virtual tap layer, there's a number of ways to be able to get at this data. And whether it's through, through the hypervisor itself, or there are also virtual taps that are sold by the network packet brokers that are out there. AppCon, Anui, others, they sell a virtual tap as well. This is really by far the better alternative. Install that virtual tap. It has the ability then to make physical connections back into the virtual machine. We make those physical connections, right, and we can now make that physical connection and bring it back to one of our appliances where we have the disk space available there, right, to store packets, the processing power, everything is there to be able to handle that virtual situation then.
Mm-hmm. So you would rely on third-party taps and automation to bring the data to you, and then you would analyze it.
That's correct, or rely on, like I say, some of the new functionality that's coming out in vSphere and other ways where in some cases people are starting to build it in, so we could take advantage of it there as well. But right, this is not necessarily one of our core competencies to do that. Our core competency is the analysis of the packets. So yeah.
By the way, speaking about virtual networks, with all this fancy new overlay technologies coming out, can you decode things like VXLAN or MVGRE on your appliance and sort packets into the right virtual networks based on, let's say, VXLAN tag?
Those are things that are on our roadmap. We understand the value of doing that, but actually we don't do that today, and it is it's quite a problem to solve. Back to what are some of the hard things that are out there. That's one of the harder things. Encapsulated protocols are really hard from a deep packet inspection perspective.
I know.
Yeah.
That's why I'm asking.
I know too.
Kind of along the same line. So if somebody needs a dissector for kittens over token ring, how do they go about getting? I mean, is that just feature requests or?
Yeah, it typically is a feature request, and if we've seen it more than once, typically even if there's several ways of approaching it. So if it's something that's truly unique to somebody, I mean just truly unique, right? We'd never be able to. No one else would ever want to take advantage of it. It can still be built in because the layers that do the protocol analysis are kind of, they're separate files, very easy to build in. So we can do a custom engineering type approach with somebody like that. They're quick to build, and we can build in support for new decodes and new protocols quickly that way. If it's something that looks like it would be widely used, then typically it's a feature request, and we're going to work on it the next time around because we see the value of it. So there's several ways, and customers can't even do it themselves. I mean, we publish our APIs for building decodes and that kind of thing. So if somebody has something unique, it's something people shy away from, but it's actually really quite simple, and we have a very clear set of instructions that can allow people to build their own decodes.
Talking about decodes and clouds, you can usually get the name of the virtual machine and its MAC and IP address from some orchestration system. Could you use that in your decodes to show me names instead of addresses?
Right, we could, but that would be something that we'd have to build in, because today,
of course,
everything we do today is from the packet inspection. We don't, like, even when we do VoIP, right? We're not pulling any data out of a call manager. It's just not everything that we're accumulating is from, because we've looked at a packet. But right.
So you're not using any external name resolution.
Only in our name. We have a name table where you can go set that up, so you can tie an IP address to a name, and you can import into that. But that is the only place that we do that today. It's just at the DNS IP address level.
So in theory, I could build that name table by pulling data from the orchestration tool, dumping it into your tool, and then I would see the names.
That is correct.
So
another glue to add.
Is there a possibility for integration with a third-party tool, say some other network analysis tool that's out there, detects an event that does in such a time, reach into the wild packets capture engine, pull out a group of packets that could then be applied to that problem event they detected?
We have APIs that are available, that people can do that. So we don't have that integration built in with anybody today, but we've certainly had that conversation with other companies, especially that are on the flow-based side, right? That might want deep packet inspection, and we actually leverage that set of APIs ourselves. We have this product I mentioned called Watchpoint, where we basically, for our own data, we represent it as flow-based data stored in a database, and then we can also take in NetFlow and SFlow, and from there we can actually go retrieve packets. So we use that API ourselves, and we can certainly make that available to other people.
There is this underlying scripting language that virtually all the features in the analyzer are available through a scripting language. And so people can use this for automation as well as on-demand processing like that. So if you know what you want to do under program control, you can create a new capture or upload, download the data that comes.
Now that you opened that can of worms, can I write my own script that would be triggered by an event, or that would be like an event filter to recognize the event and then trigger something on the outside?
Trigger being caused externally or internally to the program?
Well, trigger being caused by a certain combination of packets. So you have a certain stream of packets, and I would like to write a custom trigger saying if this thing happens, trigger something externally.
So if the trigger can be defined as a filter in the program, I think you can do what you want to do.
Okay.
So, but it's limited by what the filter can capture, basically. That's
fair.
capturing.
You skipped that interesting slide.
Oh, can we go back to that? Was it really?
Yeah, this one, capturing in the VM guest.
That one right here.
Yeah.
So, I mean, yeah, in the, what we were talking about there, it's kind of really a lousy picture, but what my point on this slide was, when it comes to, capturing in the cloud, that's where things get a little bit trickier. So if it's infrastructure as a service and you're, for example, just renting space from Amazon, you can still get a capture point out there in the cloud. You can do what I had mentioned earlier with this, Omni Virtual, running, our capture software actually out there, in the cloud. You take some resources to do that. We actually do also have a very thin version that you could run out there that would really require almost no resources, but it would require that the packets would have to come back over the network. But if you're only doing some remote troubleshooting, that might be a good way to do it. So infrastructure as a service we can kind of cover, but when it becomes things like software as a service, it's much harder, right? Because we don't have a visibility point, and the supplier's not going to, for the most part, let any enterprise have a visibility point. So all we can do is round trip analysis then at that point.
So Omni Virtual would send the captured packets over the network to your console, or would it store it locally in the file system?
Right. Two approaches. Omni Virtual itself would store them locally in the file system and do the analysis locally, but it's going to have a larger footprint. And then we have a thinner version of really of the same software. We call it OmniPeak Remote Assistant. You could actually run that out there on a case-by-case basis. It's very thin, 500 kilobytes, but it would send the packets back over the network. So you have to make that trade-off as to what's more important to you in terms of the bandwidth or the 24/7.
So you could use that for functionality like remote Wireshark. So instead of firing a Wireshark on that machine, you would just start capture and send the traffic over to your console and then inspect it in the console.
That's correct.